Hi, I'm Jadi and hope you are doing well. I was checking the source code of the Vim for some tests and see how it is testing, using its own scripting language, and found out a fun command which I've never knew about. Decided to check the source code and thought, okay, it's good to share it with you guys so you can see the source code of a very professional program, write C or even add a new command there. This could be fun. I kind of assume that you know about the Vim editor, which is the VI improved. It's an editor used by many professionals for their coding, and even if you don't like it, learning curve is very slow. You should know it because in many cases, all the servers, your Unix systems, your Linux-based systems uses Vim to do the everyday work. In most cases, you have it. You can just run Vim. You have it here, and the fun command is the smile. I have never seen this. It makes user happy. First, I will check the source code of the Vim to see how this works. Meanwhile, we will read some professional C. Afterwards, we can even try to add a new command to the Vim for fun and for profit. Later profit in your professional life. Anyway, if you want to see the source code of the Vim, go to the github.com/vim/vim. It's here, VI improved. From here, you can go and download it. Or if you want to work more, you can clone it. I've already downloaded it. In our terminal, let me make it a little bit larger. I can go here. /temp mkdir vim cd vim cp vim master from downloads. Vim master here. Unzip Vim master. I've downloaded the zip file and opened it here. We can check it in VS Code, which is nice, easy, and everywhere we can have the same thing. Okay, it's here. I was checking this source code. In the beginning, I was checking the test dir. There are different tests. One of them was test assert. And as you can see, this is done in the Vim scripting language. This is a Vim script. So it tries different functions and sees if this assert or not, if it runs correctly or not. My lovely smile, which I saw and catched my eye, was this one. It says function test user is happy, smile, run the smile command, sleep for 300 milliseconds and end the function. This was where I saw, oh, there is a smile command, and just went, ran Vim, tried to smile, and this made me happy. Hopefully it does the same with you. But if you want to see how this is created, this is an external command, so I can go to the, even if you don't know, you can just search for it. Okay, this is a smile. You can try and see which files do have a smile in them. This is text Vim, so this is a Vim file. We are looking for C files or header files. It is here. X commands.c has a smile function. X smile. It works like this. Let's read it. It is fun. It's always fun to read code. You will see how professionals are programming, and additionally, you will get better and better in your own programming and your language. Many of us do know C, but if you open a real world C code, in many cases it's difficult to understand. Here I'm reading the source code, so you will have a better understanding on how real programmers in real world in industrial projects do use programming languages. Here we have the C. Okay, it's a small function. X smile does this. First, it defines a array of static character, pointer code, two different strings. That's why you have this here. So two different strings with some kind of strange data. But as soon as we read the code, we will understand what it does, obviously, because this is the whole code. So what we have, it defines a character, pointer, defines n, and defines r. Calls message start. Most probably does something like preparing, initializing the buffer for something. Message put character \n. We know this is enter. So goes to the next line. Then it says for I equals 2, while I is smaller than 2 equals 0, sorry, while it's lower than 2, I plus plus or plus plus I. No difference in this place. So most probably it tries this first, this next, because it says for code I. So on the first time it's code 0. The second time this is code 1. Code 0 is this. Code 1 is this, the whole thing. These are two strings, as you can see here. Start with this, and if you go to the end, finishes with this one. Although it includes some double quotes here, but it's / double quote, so it means double quote itself. Do not close the string. And you know, in C, when you have a string, it works like this. When you have a string like Jadi, it means you have a string. If you have a pointer here, the first pointer will go to the J. If you add to it A, D, I, and then a 0 character shows the end of the string in the C word. If you go with hex, that would look like this. I have a hex. This is it. Anyway, these are kind of basic C, if you remember your C and if you studied your C. But even if you have not, it's totally understandable. So it creates a loop, first one and second one. Okay, first for P equals code I. So first time it's equals the whole thing here up to the end. While pointer P is not null. Null obviously is defined. This is not part of the C, so define null to the 0. Same thing we talked about. So this will be translated to this, so 0. While the pointer is not null, continue adding to the pointer. So on the first run, it will be 34. Then it will be a space. Then it will be 4. Then it will be O, and goes up to the end of the string where it finishes with a null character, because this is a C programming. It says, okay, if the character is X, message put char \n. If X go to the next line, it's like an enter. Otherwise, let's have a look to our smile and see if we can see all this. Ah, yes, it's here. Look at here. We have some spaces, then we have 4 O's, then we have some dollars, then 4 O's, then it goes to the next line. Obviously, we can see the same thing here. 34 spaces, 4 O's, $14, 4 O's, then an X. Go to the next line. So we found the first line. And it works like this here. Let's go to the code. First time, go through this, then go through this. When going through this, go one by one. If it's an X, go to the next line. Else, if it's not X, N equals whatever P points to. So, at the first run, N is 34. So it will be 4 N equals 34. Now add 1 to the P. Now P points to the space. While n greater than 0, what to do? If p, which is now space, is O or is $, message put char with attribute, most probably do it colorful, print the p. Otherwise, put character p itself. So if it's O or S, calls this function and prints it colorful. Otherwise, it will print it normal. So for n equals 34, while n is larger or greater than 0, minus minus n, print space. This will print 34 spaces. Next time, the loop is finished, p is 4, p points to 4, so n will be 4. It says for n equals 4, while n is larger than 0, minus minus n, print O with this function, which most probably adds some color. I guess this adds some color because this is here we have it colorful. This is how it works. And if you reach to the x, go to the next line. Very, very easy. You have a pattern here and this prints it there. When finished, message clear EOS. On your editor, you can always do wait here, stop here, and it says make the user happy, message clear EOS. Most probably it finishes the character. Anyway, this was a very easy and straightforward function, but you're reading the source code of the Vim. This is cool. 2 fun points. One question, if you have asked, I'm going to answer now. Why it says for n equals 34 while n is larger than 0 minus minus n. We normal people will write for n equals 0 while n is smaller than 34 n plus plus. This is how we normal programmers do. Let me explain the question once more. You want to print 4 O's. Here it says for n equals 4 while n is larger than 0 or greater than 0 minus minus n. We would say for n equals 0 while n is lower than 4 plus n or n plus plus. This is more human-like. We are counting 0, 1, 2, 3, okay, done. But here, the Guru programmer have written n equals 4, then 3, then 2, then 1, then finished. Why is that? Why we are incrementing and they are decreasing? Fun answer, because of the performance. On the CPUs, as you know, when we compile this turns into a assembly code or machine code. And machine codes are using CPU instructions in assembly to run. And on every single CPU, there are commands like equal 0, jump if 0, jump if not 0, jump if larger than 0. This is one assembly command. Jump if larger than 0. So this loop creates an n. One of the registers will have 4 in them. Then they will be checked if this register is larger than 0. One command, because we have commands like jump if 0, jump if greater than 0, and this kind of jump if not 0, and then n will be decreased. But here the assembly code will be like n is 0, one register will have the 0 in it. Then we have to compare this with 4, and CPU cannot do this directly. So it should create a 4 in memory or in a register, then compare these two, then add 1 to this. This will be 2-step. An assembly word checking with anything other than 0 is more complicated, is more difficult, and needs more instructions. Because if you are saying if A is larger than 42, 42 should be somewhere in the memory, A should be somewhere in the memory or registers, and then you have to compare these two by an assembly. But if you want to say A is larger than 0, there is one specific instruction for this, and you don't need 0 somewhere in the memory. You just call larger than 0 on A, and you will have the answer. That's why Guru people do like this, because this comparison is much faster, maybe twice or even more faster than this. But in the real world, first, in the Vim, you don't need this specific optimization here, although it's fun to have. Programmers are showing that we understand this and we are good programmers. In addition, most of the compilers, when they compile your program, will do these kind of optimizations. We can check this later in another code. This is becoming long. So this was the case. If I want to compile this, as you saw, I had the source code here. I just had the source code. So when I say Vim, I'm entering Vim 9.0 something something. And if I say which Vim, you can see this is the Vim. So this has nothing to do with what I downloaded. I just downloaded the source code to show you. If I want to compile this, I can say configure cd source configure. Configure will check all the dependencies, will configure things for your CPU and these kind of stuff, and then we have to make it. I will do as soon as the configure is done. Later I will try to add one command to the Vim so you can see, and you can do it for yourself, practice, whatever. Who knows, maybe someday you will add a real command to the Vim. So we did the configure, I will do the make. Make will take longer on the first run because it's building everything. At the same time, I can show you that there are always files like readme or install and these kind of stuff which describe how to install this project. For example, it says what is Vim, distributions, how to install Vim for sure, and different things. What is Vim, distributions of the Vim, compiling the Vim, how to install the Vim. For each system it has its different file as a helper. For example, we have to check this. Let's readme on the Unix. Find iname this. This is it. Readme dir. So it's okay. This file bilan. Anyway, make install. Okay. So we did the first dot configure, then we did the make, and later if I want to install what I've made on my system as my general Vim, I have to do a make install. We won't do that. Let's wait for this to finish and then we can add our own command. At least try to. Okay, it's back. Now it is built into this temp Vim, whatever we were, in the source directory. See, if I run the source Vim, I have my Vim, which is version 9.1. General Systems Vim was 9.0. And for sure we have the smile. So, if we want to add a new command, that would be a fun experiment and you can do for yourself. And it's very straightforward because I have this function. I can come here and say, okay, I have a new command which is called boss. It will tell who is the boss. I can do maybe like this. I will create a string. It says Jadi is you are the boss, because it can have different users. And we will say, okay, message start, go to the next line. We don't need this, obviously. And then we say for P in code, while this is not null, you have not reached to the end, go forward. If it's X, go to the next line. Otherwise, you go with printing the character. Okay, this should do it. And we can add some X's here to go to the next line, and we can add some X's here to go to the next lines. Is this okay? If P equals X, print, else. No, we don't need this, because there is no numbers anymore. What? I prefer it like this. Okay. Save. But here we just added a function. This function should be configured somewhere, called somewhere. And if you don't know where it is, there should be a header, but I can search for xboss and see, x smile and see where it is used. On the commands, I did this. Okay, on the headers, very logical. On the headers, I need it. It seems there is something. X command expands to command smile, which does this. And I say I have a new command. It's called command boss. It takes this boss, and who has it? Boss. And also there is a pro, which most probably is a prototype. I can guess during the making or configuration, this expands to whatever is needed as a header file or something. So I would say I have also this. Should be cool, because we had 3 here, so I just copied kind of whatever was there. If I want to work, I have to say make. One more make. It will create only the needed files. This should be much faster. And then we can try our new command. We have an error here. I had an error in my C code. What says? This is the problem. I was looking at this and saying, okay, this is correct. So one more make. Sorry that I wasted your time. But it's always good to see errors, to fix errors. First error was error expected this or this before character. So before this character, I would needed something which is semicolon. One thing they don't teach in universities or programming classes is reading the errors, solving the errors. That's the most problematic part. Anyway, let's wait once more. Okay, this is done. Now let's try it. I have to do source vim. It says detected while processing. Did we broke something? It says I cannot read this on line 2, internal error. If you can report a bug. We should not, because we broke the source code. Command table needs to be updated. Right? Run, make command indexes. This is the story. Vim tries to be high performance. So it creates something like a command table. Whatever command it has, it saves them in a table. From the first letter, it tries to say expand to whatever it has, and these kind of stuff. This is why when we added a command, we needed this to be run. Make cmd indexes. Not n, cmd id. Okay, let's go to the source directory. This runs this, but this is the Vim on my machine. I will try the same thing here. You understand my point? When I say Vim, this is the Vim which runs. But here I need this Vim. So I will copy this and say run it like this. And still it breaks. I can do a make here so it makes whatever it needs. I'm in the source directory, so this was part of the make, what it was suggesting. So I ran this and it runs whatever make it needs. Now I will go with Vim. Now I'm in Vim 915 and I have the smile command, which I already had. Hey there, I have a new command. It's called boss. And we have a new command in our Vim. I hope you liked it. My idea is showing you that you can read the source code on the highest level of programmers writing the most, I wanted to say mostly used editors, but maybe the best editor, maybe it can be the Emacs, but Vim. I'm not starting the fight, but you can read the source code of the highest level in programming. This is the best thing that can happen for any profession. Read it, understand it, change it. This way you can become one of the best people. My suggestion is for you to add a new command for yourself. If you want to dig more, add a command which whenever you type, insert something in your text or whatever you like. Go forward and learn. I was Jadi and I was super glad if you've continued up to here. Tell your friends. I'm trying to have a good channel for real programmers. Enjoy.